A very warm welcome to All India Shri Shivaji Memorial Society's Institute of Information Technology. I am A Jamadar from Department of Information Technology. I am here to discuss data structure and algorithm subject. In that one, we will be discussing today about time complexity. So what is time complexity? First we'll understand, then we'll try to find time complexity of some well-known algorithms. So what is time complexity? See, whenever you want to take a tour, say you want to go on tour or visiting some places. So what do you do initially? You try to know the time required to reach over there. What would be the time required? Say you want to go to Delhi. Say from Pune, you want to go to Delhi. What is the time I need? So there are different ways. By rail, if you go railway, then the time is different, say T1. Then by plane, if you take a flight, say it is T2. And if any other means you want to have, then that way different times you need. So you check what is the amount of time required. You will take different paths. Say if you want to go via Mumbai, it is possible. You can go via Dound, that is also possible. So which is the best route here for me, that you will find out, and accordingly will make a decision. That's what here time complexity we mean. Say if you want to move from Pune to Delhi, if you are going via Mumbai, what's the time complexity? Or if you are going via Dound, what is the time complexity? This way the time changes by changing the route. Here also, when we write an algorithm for some basic task or some job, what is the order of time required? Say we perform basically some basic tasks. There is some basic task you are performing in your algorithm. How this basic task, how many times you perform this basic task, that's what the time complexity. If you are performing only once, then the time complexity we represent with the notation big O of 1. It is constant. It is not a variable because it is only once we are doing it. Say the same basic task if you are doing for n times. For n times you are repeating that basic job. Then what is the time complexity? It is big O of n. Say for instance, I will give you an example. Say there is a class of n students. And you want to search a student. So what do you do now? You find out like you will try to know what is the name of student to be searched. So say XYZ is a name of the student. Among these n students, XYZ is there somewhere. You have to find out. So they are sitting like this. So you will not announce who is XYZ. What you will be doing, in sequence you are searching. Say he is the first person, you will ask him. Then the second person, are you XYZ? You will ask. No. He'll say no. Then he'll also say no. So this way you will come up to all n students. So this is what you are doing. You are checking, is he the person XYZ? That is the basic task. If you do it only once, then what is the time complexity? Big O of 1. If you check with all, is he XYZ, up to n you will check. In the worst case, what happens? The nth person may be XYZ, or he may not be there in the list at all. So in that case, how many times you compare? N times you compare. So that is what the time complexity we say. So it is a searching algorithm, linear search algorithm. Big O of 1 is the best case. If the person XYZ happens to be the very first person, that is the best case we say. That is the best case efficiency, and there may be chance that in the list that person may not be there, or the nth student may be that person whom you are looking for. That is the worst case we say. So this is how we find the order of time. It is big O of n is the commonly and widely used asymptotic notation. We call these as asymptotic notations. asymptotic notations. Now let me give you quickly some of the time complexities I'll give you now. Just a second. So here we'll find, say you are writing a program to swap two numbers, to program to swap two numbers. So in this scenario, what is your job? You will be writing the basic swap logic. Say in T you will take A, and in A you will take B, and in B you will take T back. This is your basic job. So irrespective of the two numbers, the time required is same always. There will be no change. So you give any two numbers, all the time required will be same. So it is a constant, we say big O of n. Now you are swapping, say you are swapping n times. So the same job you are doing, n times you are doing. Say for I0, I less than n, I plus plus. This part, swapping part you are doing here, swapping two numbers. You are asking the user what are the two numbers, and then you swap them. So this is how the basic task swapping is done n times. That's why what is the order of time, this one time, the order of time will be big O of n. It depends on n. More number, n is very large, say n is very large, then more comparisons will be there, more time it will be, more time. Lesser value of n, less time. So it is the changing with respect to n. That's why we say the time complexity of this swapping or this loop is, this program is big O of n. Similarly, now you take any loop based program that has order of big O of n. If you are nesting the loop, say you are nesting one loop inside the other loop, normally for reading two-dimensional arrays, read 2D array, display 2D array. So these require nested loop, one loop inside the other loop. Then it is what? Big O of n into n it is. That is big O of n square. And if you perform multiplication of two matrices, two-dimensional arrays, there you use three nested loops. One loop is nested in the other, and these two again nested in the third loop. That way the time complexity will be big O of n cube. Similarly, I can give you more examples here. Just let me give more examples. Say you are, what is the time complexity? Time complexity of checking whether the number is prime or not, checking whether the number is prime or not. So you normally have n comparisons. The best known algorithm is there that will only check for root of n times. Say for I is equal to 2, I less than or equal to square root of n we say, and up to square root of n we check and we compare. So this way the loop is running up to only square root of n. That time, how you represent the time complexity? It is n raised to half, because n raised to half is, it is root n. Similar way, whenever you have one loop, it is big O of n, you can say. And we'll go to data structure algorithms now. Say stack. What is the time complexity of push operation? You are doing only once, you are pushing, you are storing only one item. So it is again a constant big O of n. Say if you take a linked list, what is the time complexity of adding a node at the beginning? You don't need to traverse the list. So the moment you land, get the head, you add. That way it is again constant. But at the end, rare end, if you want to add, you have to traverse all n nodes. That time it is big O of n. This is how you find a time complexity, and normally in interviews they ask a time complexity of such algorithms. Normally sort algorithm, say bubble sort, it has big O of n square. Then same way insertion sort also has a big O of n square. Then quick sort has worst case big O of n square, and merge sort merge sort it is big O of log n base 2. This way we have. So I hope you enjoyed the session. We'll again come with a new topic. Thanks for watching.